Today I want to talk about how to build a slightly more complex program in TinkerCAD Circuit Simulator using the text-based Arduino program. So I have just opened one of the starters, the Arduino starters. I went down and chose the tone keyboard, and I'm going to make some modifications to it. So I'm going to start by renaming it. I will call it Keyboard Plus. I'm going to start with the keyboard, but I'm going to add some more stuff. So first, it would probably help to take a look at the code as it exists now so that we know what's happening and I can decide what I want to change. So if we open up the code interface and make sure we're on text, up at the top in the header section, you can see it's a keyboard. It plays a pitch that changes based on the inputs, those buttons, those are going to be the inputs. It has some notes on how it should be wired up. If we go down a little bit, you can see the pin mode has those 4 inputs set up, the 3 buttons and the speaker buzzer. We have one variable set up so far called POS. I'm betting position, maybe. Okay, so if we go down a little bit into the loop section, you can see if the button A0 is pressed, we want to play this tone. And if A1 is pressed, we want to play this tone. And if A2 is pressed, we'll play this tone. No matter what, once we've done that, we're going to delay for 10 milliseconds, and then we're going to go start over. So let's run this simulation and see how it works. Okay, so it's by default not making any noise at all. If I hit the button, okay, so we can see we have 3 different notes being played on those 3 different button presses. There we go. I'm going to go ahead and stop this simulation and close the code for now because now I need to figure out what I would like to add. So I'm going to go to Components and go take a look at what I might want to add. So maybe the first thing I'm going to add is an on-off switch. Okay, so I'm going to, let's see, maybe I'll put it up here. And so I'm going to use this on-off switch to make it so that this keyboard will only function when my piano keyboard is turned on. So in order for that to work, I need to wire up this button. If we look at this guy. Okay, and you might remember how to wire this up from a previous lesson, but if you don't, we can always go look it up. So let's go take a peek on SparkFun's. No, I'm going to show you through Canvas. That makes more sense. So if we go to our electrical engineering class and we go to modules, we can look at the SIK circuits and think about how we hooked up a button. So let's see, buttons, push buttons, there we go. So a switch is very like a push button. And so in the same way that we wire up a button, we can wire up a switch. So let's take a look. The button's got 2 legs. One leg is connected straight to ground. The other leg has 2 connections, one going to the board and one going through a 10K resistor to power. So let's go do that. In the case of a slide switch like this, we want to connect one outside and one common, not the 2 outsides that won't work out the way you want it to. So I'm going to connect this terminal 1, I'm going to take that one straight to ground. I like color coding, so I'm going to make sure that guy stays black. I know I'm going to need a resistor to connect the common leg. And this is currently a 1K resistor. I want a 10K resistor. There we go. I'm gonna move this down one more so that I have room to get a wire out of the same leg that has the resistor on it. Let's see, we'll take this over to number 2. Okay, and it looks like I'm already using green for something else, so I'm going to use purple. I like purple. All right, you can see that the buttons are set up pretty much the same way. They have one wire going to power and one going to ground and the board. Oh, did I do that wrong? Going to power and the board. Going to power and, oh, well, they did the opposite way, but mine is going to work just fine. Okay, as long as you have a set, the resistor attached to the one going to the board, and this one connecting to the other, whichever one you didn't do, power or ground, you're going to be just fine. All right, so we have now added a switch. Oops, I'm gonna update my video here. All right, we have now added a slide switch, which is good, but the slide switch won't do anything if we don't add some code to run it. So I am going to add some code. This will be a constant integer because I don't want to change it ever. I'm just going to set it up one time, and it will be my slide switch. And I plugged it in to number 2. So in the pin mode, I am also going to set up 2 as an input. You know what? We have a 1 and 2. I'm not going to leave this in 2. I'm going to put this, oops. Oh, so unhappy with me. Hold on. I'm going to put this over in 4 just to prevent any confusion about whether it's the analog or the digital that I'm reading. And right here, I don't have to put 2. I can put slide switch because I just set up a variable to hold that. Okay, so now I have an input of this slide switch. The other thing that I'm going to set up right off the bat is my serial monitor because it is just so useful. And in fact, I'm going to use it right away to make sure that I set up my switch correctly. So I'm setting up a print line to read, digital read. Refer back to the digital read video if you're not sure why I'm choosing digital read right now. Okay, so this line says, go look at pin 4, right, where I have my slide switch attached. Read digitally what's happening there and print it out to the serial monitor. That's all this line says. It's not doing a whole heck of a lot. Now I am going to comment out the whole rest of my program, basically, because I'm just going to use the serial monitor to confirm that my slide switch is set up correctly. So I'm going to start my simulation, turn on the serial monitor. Okay, and we can see that right now it is reading 0. And if I flip the switch, it is now reading 1. So that is working just the way I want it to. Back to 0, back to 1. Excellent. All right, I can stop my simulation. Good. Okay, so I don't need this line anymore. What I want my switch to do is I want it to determine whether or not my keyboard is running at all. So I am going to set up an if statement that will check, go read, oops, get my capitals right, go read my slide switch, and if it is a 1, sounds like on, right? 1 for on, then I want to turn on the keyboard. And I don't need an else yet, but I could have in there otherwise turn off the keyboard. But I have to figure out what turn on the keyboard means in this case. So what it could mean is that I'm going to take all of this stuff and move it inside my switch statement, or my if statement that reads the switch, not to be confused with a switch statement. Okay, so I'm gonna fix some of my tabbing here. One of the things I really do miss about the desktop version of Arduino is it has a really great auto format feature that I don't think this one does. I do miss that. Take out these comment outs. Okay, so now I'm going to enter my loop. I'm going to read what's happening on the slide switch. If it is a 1, I will go ahead and start running through this keyboard code. If it's not, I won't. That should be pretty much what happens. So let's say this will check the slide switch to turn on the keyboard. All right, let's see how we're doing. So it's off right now. If I press the buttons, nothing should happen. Good. If I throw the slide switch, there's my keyboard. Excellent. So far, so good. So let's add something else. Stop the simulation. Let's also add a potentiometer. A potentiometer needs 3 connections. It needs one going to ground, which I will make black. It needs one going to power, which I will make red. And it needs one going over to the board. I'm going to plug this one into A3, and we'll make this blue. Matches the potentiometer. Okay, so a potentiometer is an analog input. It's like a dimmer switch, right? It has a whole range of values that can be read from it, and it works great in an analog port. And so now I'm going to add this potentiometer to my code. So over here, I'm going to add to my A's collection in mode E3, also an input. And I'm going to, before I do anything else, do a serial print line. Excuse me. That is going to analog read A3, where I just plugged in my potentiometer. And I can even leave this. I'm just not going to turn the slide switch on, so none of this stuff will happen. All right, so we are going to start the simulation. And right now, it should be reading 0. Oh, and there we go. We jump. 200s, 300s, 400s, 500s, 6s, 7s, 8s, 9s, 1000s. And back down we go. Cool. All right, that's working just fine. So what I'd like to do is I would like to use my potentiometer to allow me to change kind of the pitch of my keyboard. So what I'm going to do is I'm going to stop the simulation first. I'm going to introduce a new variable, and it's going to be an integer. I'm going to call it change. Sure, I'm going to call it change. And I'm going to start it out at 0. And then down here, the first thing I'm going to do is I'm going to set change equal to whatever I am reading out of the analog potentiometer. So it's going to read those numbers we were just showing. Actually, you know what? I'm going to go ahead and also print it out. It certainly isn't going to hurt to let us see it at the same time. So I'm going to do a serial print line. And now that I have stored that value in the variable change, I can tell it to just print change. Shorter to type. Okay, so this line is going to read what's happening on that analog in and store that value in change. Then I'm going to print it out, and then I will go about looking at my keyboard. On my keyboard, here's what I would like to do. The tone, see where it says play tone. This is, I believe, you know what? I'm going to show you how to look it up. No need to guess. Google is your friend. Arduino tone. So we're going to go look at the Arduino reference for what the function tone does. So if we scroll down a little bit, you can see the syntax says that what we need is a pin, so what pin it's playing on, frequency. Frequency is what controls how high or low the sound is, if you remember that from physics class, and duration. And that one is listed here 2 different ways because pin and frequency are required, duration is optional. Let's go back and take a look. So currently, the way this program is set up is that it's saying I'm going to print out on pin 8. So there's pin 8 going to the speaker. This is the tone that I want to send, and here is how long I would like to send it for. So here's what I'm going to do. I'm going to add to this tone number, and I'm going to say I want you to add whatever my change value is, and we'll see what happens. So remember, when we first start the program, it should be 0 because I set it to 0 initially. And then we'll be able to see on the serial monitor what's happening with this. And then we should be able to hear, when we press the buttons, how it changes that pitch. So let's go give it a try. Okay, so right now it's off, right? So none of the buttons are going to work. I'm going to turn on the keyboard. And now if I press the buttons, okay, so now let's try changing that change variable. So now it's 164. So instead of 440, it's going to send the tone, what, 604? That's kind of cool. See, we can go a little bit higher, 511. So this is going to print out, or it's going to send 951. But that's very high. What happens when we go all the way up? So 1023. And we're going to add 440 to that. So high. All right, so, well, maybe a tiny bit screechy. It works pretty well. Awesome. I'm going to hit stop. So here's the next thing that I want to show you with this. This is working pretty well. We've got buttons that are playing this speaker like a keyboard. We can turn our whole keyboard on and off. We can change the pitch of our keyboard with our analog input over here. So what could we possibly do that would be more? Well, what I want to show you is how to make a function. So here, when I say turn on keyboard, currently I have this all pasted in here, but I could also take this stuff out and make it its own function. And we'll call it keyboard. So your functions need to have opening and closing brackets, just like loop does. They need to go after loop in the order of your program. And then here's how you tell it you want it to happen. You say, I would like to run the keyboard function, just like so. Make sure all of my tabs and everything line up nicely. Okay. That's looking pretty decent. Let's go make sure it still works. Okay, so nothing's gonna happen right now. Turn my keyboard on. I already have a change value going over here. And that works great. Okay, so it is using the value stored in this change variable up here all the way down in this function, because this is a global variable. It's one available everywhere in the program. So let's watch what would happen if I didn't put it up there. So I'm going to move this one inside my loop. And maybe I'll just do it right here. And now let's watch what happens when we run this program. Start the simulation. Oh no, and it's all upset at us. So what's happening is the keyboard function is looking for the change variable, but the change variable is only available in the loop function, in the loop part of the program, okay? Because I set it up in here. Now, can you get a value to move from one to the other? You actually can. So here's what I could do is I could take change and pass it to the keyboard function. But that's only going to work if the keyboard function is expecting to receive it. And for good practice, you don't want all these to be all the same name. I have named it here. I'm using it here. I'm passing it on to the keyboard function here. But that does not need to be the same name down here. I will call this incoming for incoming information. And so here, whatever that incoming information is that I have sent, that's where, oh, gotta spell things right though, that really helps. That's where I'm going to use it. Okay, so now whatever gets passed to the keyboard function will be used here, here, and here. Let's give it a try. Oh, nope, I made it worse. Void loop error, keyboard was not declared in this scope. So it's not void anymore, I believe. $39. Oh, it's not passing back. I'm gonna leave that as void. I'm gonna undo. What if I leave these guys as change? And sometimes it's hard popping back and forth between too many languages. Are we any happier? We're not any happier. It didn't like keyboard. Why doesn't it like keyboard? It really should. All right. Well, I will come back for passing things in and out later. I want to show you guys this working correctly. Am I back to everything being spelled right? Oh, that's an awesome sound. Oh, did I delete a wire? I totally deleted a wire. That's not good. I wonder how I did that. Well, weird sounds abound. And blue. Hey, there we go. It definitely helps to have all of your wires plugged in if you want it to work predictably. Goodness. Okay, so we looked at how to, I don't know why you're still unhappy with me. Clear. Okay. I also need to change this section up here. I need to change my header to match what I've been doing. Today is the 12th. Keyboard plus. So it is based on the keyboard example TinkerCAD circuits. And so it does all of these things, but I also added a on-off switch and potentiometer to control pitch. All right, so we added 2 new pieces. We looked how an on-off switch worked. We looked at making our own, I don't know why you're still unhappy, I'm gonna ignore you. We looked at adding our own function. I'll come back to passing things in and out of functions on a future video. And we refreshed our serial monitor, looked at analog and digital. So this is getting on towards being a little more complex. I made sure to label my changes so my comments reflect how the program works now. That's really important, don't forget that. I made sure that my variable names made sense for what I set them to be. And this is looking pretty good. And then I made sure that my header section was updated too, and that I gave credit where it was due. Okay, that is everything that I wanted to show you today.